how could humans endure months of near-total darkness while temperatures plunged far below freezing and still survive with limited resources? For the Inuit people, this was not merely a challenge of survival, it was a test of ingenuity, observation, and an intimate understanding of their environment. Life in the Arctic is defined by extremes. In winter, the sun barely rises above the horizon, and the cold penetrates through every crack, demanding constant vigilance. Within these harsh conditions, Inuit communities developed highly specialized strategies to control heat loss, manage the dim light of oil lamps, and maintain oxygen levels inside their homes, all while navigating the seasonal rhythm of darkness and cold that shaped their entire way of life. The first layer of this adaptation was the architecture of their shelters. Unlike modern homes with insulated walls, electric heating, and ventilation systems, traditional Inuit dwellings were crafted from the materials immediately available in the landscape: ice, snow, sod, driftwood, and animal skins. The igloo, perhaps the most iconic of these structures, was far more than a temporary shelter. Its dome shape was carefully engineered to minimize surface area relative to interior volume, a principle that significantly reduced heat loss. The compact curvature prevented sharp corners, which are naturally prone to radiating warmth into the cold air outside. Builders dug slightly below the snow surface to create a semi-subterranean foundation, trapping the slightly warmer earth beneath and insulating the interior from the relentless Arctic wind. Each block of compacted snow acted as a natural insulator, with tiny air pockets within the ice slowing the transfer of heat. Inside the igloo, Inuit families arranged their living spaces with deliberate attention to thermal zones. Sleeping areas were elevated on platforms of snow or packed earth covered with animal skins, placing the body above the colder ground. Floors were layered with furs, moss, and carefully dried grasses, which added insulating layers and absorbed residual moisture. The central area, slightly lower, became the cooking and heating zone, where quillik, oil lamps fueled by seal, whale, or caribou fat, provided the primary source of heat and light. These lamps were shallow, carved from stone, soapstone, or carved driftwood, and ingeniously designed with a wick made of moss or woven plant fibers. The flame, though small, was carefully maintained. Its warmth radiated across the dome, and its glow illuminated the interior just enough for tasks without wasting precious fuel. Fuel conservation was critical. In the endless night of winter, every drop of animal oil counted. The Inuit mastered the art of controlling lamp intensity. A larger flame meant more heat, but also more oil consumption and faster depletion of oxygen. To compensate, lamp placement and the number of lamps in use were carefully calculated. One central quillik could warm the main living area, while smaller lamps provided localized light for tasks like sewing, repairing clothing, or preparing food. Families often used the interplay of shadows and reflections off the white interior walls to maximize illumination, reducing the need for multiple flames. The controlled flicker of the lamp became part of daily life, signaling when work should be done and when to rest. Ventilation was another critical consideration. While the igloo and other winter shelters were effective at trapping heat, the combustion of oil lamps created carbon dioxide and, if not managed, could lead to dangerous oxygen depletion. Inuit builders incorporated subtle ventilation channels into their structures. Small holes at the top of the dome allowed smoke to escape, while lower entrances, often covered with skins or snow blocks, regulated airflow. The airflow system was subtle and passive, taking advantage of natural convection. Warm air rising carried smoke and stale air out, while fresh, colder air entered near the base. These techniques ensured a balance between maintaining warmth and preventing suffocation, a delicate equilibrium that could mean the difference between life and death. The seasonal rhythm of Arctic life also influenced heat management. During the long, sunless winter, Inuit communities concentrated indoor activities, preserving body heat by clustering together and sharing tasks that required movement, such as preparing hides, mending nets, or tending to the quillik. Clothing was layered and designed to retain warmth while minimizing sweat, which could dampen furs and reduce insulation. Each member of the family adapted their own heat retention strategies. Infants were wrapped in multiple layers of fur, while adults used tight-fitting clothing in the coldest sleeping areas and looser layers while working near the fire. Even the arrangement of bodies within the shelter, side by side, feet toward the walls, heads near the warmer central zone, demonstrated a nuanced understanding of thermodynamics achieved through generations of experience. Seasonal darkness presented additional psychological and practical challenges. With the sun absent, natural cues for sleep, work, and meals disappeared. Inuit people relied on lamplight not just for warmth, but also to regulate daily rhythms. The subtle variations in flame intensity, combined with the communal scheduling of work and rest, created an artificial cycle that mimicked the rising and setting of the sun. This careful timing helped reduce fatigue and maintain alertness, which was crucial when survival depended on both preparation and vigilance. Even the positioning of sleeping areas relative to the lamp was intentional. Individuals closest to the heat source would wake less frequently to cold, while those farther away adjusted their clothing and bedding to compensate. The management of resources extended beyond the individual shelter. Inuit villages often coordinated activities across multiple dwellings to ensure efficiency. Community knowledge dictated when to hunt, how to store excess fat, and how to ration oil for lamps over weeks or months of darkness. Preservation techniques, such as drying meat and fat or storing blubber in frozen caches, ensured a steady supply of fuel. Every aspect of energy use, whether it was heating, cooking, or lighting, was interconnected with survival strategy. Families understood that controlling heat, light, and oxygen inside their homes could not be separated from broader patterns of hunting, travel, and seasonal preparation. Even with these meticulous systems in place, the environment demanded constant adaptation. Sudden windstorms could chill an igloo in hours, forcing quick repairs to walls or entrances. Lamp flames could sputter or extinguish, requiring immediate relighting to prevent temperature drops or complete darkness. Ventilation holes needed to be monitored for ice buildup, which could block airflow and increase the risk of smoke accumulation. Through all these challenges, the Inuit developed a resilience rooted in intimate knowledge of natural materials, thermal physics, and communal life, skills honed over centuries of observation and necessity. By mastering these techniques, the Inuit were able to turn inhospitable spaces into livable ones, creating shelters that balanced the needs for warmth, light, and breathable air. Their ingenuity demonstrates a remarkable combination of empirical science and cultural wisdom. They controlled heat loss through architecture and layering, regulated oxygen through subtle ventilation, and maximized lamplight while conserving precious fuel. This blend of practical engineering, environmental knowledge, and communal coordination allowed families to endure winter darkness and sub-zero temperatures that would overwhelm most other societies. The strategies developed by the Inuit were not static. They evolved in response to changing conditions, seasonal cycles, and intergenerational learning. Each winter, families adjusted their practices based on prior experiences, the thickness of the snow, the available materials, and the intensity of the polar night. Children learned from observing elders, absorbing skills in layering clothing, tending fires, and maintaining shelters. Every act, from carefully trimming the lamp wick to insulating a sleeping platform with moss, was a lesson in resourcefulness and survival. In the end, understanding how the Inuit controlled heat, light, and oxygen is not merely an exercise in anthropology. It is a window into human adaptability under extreme environmental pressure. Their winter dwellings were more than shelters. They were intricate systems of energy management, carefully balanced to preserve life in a world where failure meant immediate danger. Through observation, experimentation, and communal wisdom, the Inuit transformed the harsh Arctic landscape into a space where human life could not only survive but endure for generations. As winter deepened, the rhythms of life within Inuit shelters became a delicate choreography of survival. The interior of an igloo or sod house transformed into a multifunctional space where every action was influenced by heat retention, light management, and oxygen conservation. Families organized their activities with precision, often dictated by the flow of warmth and the flickering of oil lamps. Cooking, repairing clothing, and social interaction all centered around the quillik, whose flame became both the heart and the clock of the home. Its gentle heat radiated across the interior, creating a zone of warmth that dictated where work could be performed efficiently. The lamp was never treated as a mere source of light. It was a tool of survival, an anchor for daily routines, and a measure of energy resources carefully rationed over weeks of darkness. Sleeping arrangements were equally strategic. Elevated platforms covered with layers of furs and moss provided insulation against the frozen ground, while bodies were arranged to maximize shared warmth. Adults often slept in proximity to children or elderly family members, ensuring that the collective body heat was efficiently retained. Blankets and garments were layered in a specific order to trap heat while allowing moisture from sweat to evaporate into the air, preventing dampness that could reduce insulation. Sleep itself was regulated by the lamp's intensity, with families dimming the flames at night to signal rest while preserving precious fuel. In this way, human biology was synchronized with the artificial cues of the environment, allowing the community to maintain a stable circadian rhythm even in total darkness. Cooking was another domain where heat, light, and oxygen had to be carefully balanced. Meals were primarily composed of fish, marine mammals, and game, preserved through drying, fermenting, or freezing. These foods required controlled heat for preparation, as boiling water or rendering fat demanded prolonged exposure to the flame. The kulak, positioned centrally, allowed multiple tasks to occur in its warmth, but fuel limitations meant that only essential activities could occur simultaneously. Women often multitasked with great skill, tending to the lamp while preparing food, repairing clothing, or supervising children. The careful choreography of these tasks ensured that no energy was wasted, both in terms of fuel consumption and body heat. Ventilation remained an ever-present concern. The accumulation of smoke and carbon dioxide could become a serious hazard, especially when multiple lamps burned simultaneously or when cooking generated additional fumes. Inuit shelters were designed with a subtle understanding of air movement. Entrances were partially blocked with snow or skins to reduce heat loss, while small vents at the apex of the dome allowed smoke to escape. This passive airflow relied on convection, with warm air rising and cooler air entering at lower points. Maintaining these ventilation channels required constant attention. Ice or snow could block holes, winds could shift smoke patterns, and occupants had to be vigilant to ensure a steady supply of oxygen. Families developed a keen sense of the interior atmosphere, able to detect changes in smoke density or odor that indicated a need to adjust the vents or reduce the number of flames. The management of lamplight was equally nuanced. Flames were kept low to conserve fuel and reduce oxygen consumption, yet bright enough to illuminate essential tasks. The reflective surfaces of ice or white snow walls amplified light, while strategic positioning of the lamp created shadows that allowed movement without direct flame exposure. This interplay of light and shadow was not only practical, but also psychological. During the long Arctic night, dim, controlled light provided comfort and orientation, helping to structure daily routines in the absence of natural sunlight. Families learned to interpret subtle changes in flame behavior as cues for action, creating an intricate language of observation that linked survival directly to sensory perception. In addition to architecture and internal arrangement, clothing and bedding were integral components of heat management. Animal furs, skins, and layered garments were selected and prepared with extraordinary care. Seal, caribou, and fox skins were preferred for their insulating properties and ability to repel moisture. Garments were constructed to trap air between layers, enhancing thermal retention while allowing mobility. Even small details, such as stitching direction or fur orientation, were chosen to maximize protection against wind and cold. Sleeping garments were designed for both warmth and breathability, allowing occupants to retain heat without generating excess moisture that could compromise insulation. Each element of clothing and bedding functioned as part of an interconnected system, complementing the shelter's architecture and the controlled flame of the kulak. Seasonal adaptation extended beyond the home. As the winter progressed and darkness deepened, Inuit communities modified their daily routines to align with environmental demands. Hunting parties were organized to coincide with periods of lower wind or more stable ice, ensuring safe travel and reducing energy expenditure. Fat and blubber collected from hunts were prioritized for lamp fuel, directly linking survival in the home to activities in the harsh outdoors. Social interaction within the shelter was also influenced by resource management. Families often limited the number of simultaneous tasks to prevent excessive oxygen depletion or fuel usage. This required careful negotiation and cooperation, creating a culture of shared responsibility and mutual support. Even artistic and cultural practices were shaped by heat and light management. Storytelling, for example, often took place in close proximity to the lamp, with participants seated around the warmth of the fire. The flickering flame created dynamic shadows that enhanced the narrative, providing both illumination and atmosphere. Songs, dances, and rituals were carefully timed to conserve energy while sustaining morale. These activities were not merely entertainment, they reinforced social cohesion, transferred knowledge across generations, and maintained mental resilience during periods of extreme isolation and darkness. In extreme cases, temporary modifications to shelters were made to adapt to sudden changes in weather. Snow accumulation could block entrances or vents, requiring rapid excavation or rearrangement of blocks to maintain airflow and heat retention. Wind-driven snow could chill the interior in hours, demanding constant monitoring and maintenance. Families developed routines for inspecting structural integrity, clearing vents, and adjusting lamp placement in response to environmental shifts. These measures were a testament to the Inuit capacity for observation, improvisation, and proactive problem-solving under conditions that would overwhelm those unfamiliar with the Arctic. The cumulative effect of these practices was a remarkable equilibrium between human needs and environmental constraints. The Inuit demonstrated a sophisticated understanding of energy management that integrated shelter design, clothing, fuel conservation, and communal organization. Each decision, from trimming a lamp wick to adjusting a sleeping platform, was informed by an acute awareness of heat transfer, airflow, and light efficiency. Over generations, these techniques were refined, creating a body of knowledge that was as much engineering as it was cultural heritage. Survival was not left to chance. It was the product of deliberate design, observation, and adaptation. This approach extended to child rearing and the transmission of knowledge. Young members of the community were taught from an early age how to maintain fires safely, arrange sleeping areas for warmth, and interpret environmental cues that indicated changes in airflow or temperature. Practical skills were combined with oral instruction, ensuring that each generation inherited both the technical expertise and the intuitive understanding necessary to thrive in a frozen world. This intergenerational knowledge formed the backbone of community resilience, allowing families to navigate the challenges of seasonal darkness with confidence and competence. Even in moments of scarcity, the principles of heat, light, and oxygen management guided decision-making. When fuel supplies were low, tasks were prioritized, and flames were reduced to the minimum necessary for survival. Families shared warmth strategically, clustering together to maximize body heat while minimizing energy expenditure. Temporary shelters were sometimes constructed for hunting trips or travel, employing the same principles of insulation, ventilation, and controlled lighting on a smaller scale. These portable adaptations reflected the Inuit ability to transfer architectural and behavioral knowledge across contexts, demonstrating a consistent application of survival strategies. By the end of the winter season, the cumulative effect of careful resource management became apparent. Families emerged from months of darkness having maintained warmth, survived on limited fuel, and preserved oxygen levels in their homes. Their success was not solely the result of physical endurance. It was a testament to a deep understanding of environmental physics, material properties, and human physiology. The interplay of heat, light, and air within the shelter created a sustainable microclimate, allowing human life to persist in conditions that would challenge any modern society without advanced technology. The survival strategies of the Inuit also had broader implications for social cohesion and community structure. The careful coordination of fuel use, lamp management, and shelter maintenance required constant communication and cooperation. Decision-making was often collective, with elders guiding younger members in balancing risk, conserving resources, and performing essential tasks efficiently. These practices fostered a sense of shared responsibility and interdependence, reinforcing the social fabric necessary for enduring the isolation and severity of the Arctic winter. The winter experience shaped not only physical survival, but also cultural identity. Stories, rituals, and traditions were inseparable from the spaces and routines developed to manage heat, light, and oxygen. Knowledge of lamp maintenance, sleeping arrangements, and ventilation systems became cultural markers, forming a bridge between survival techniques and the transmission of heritage. The practices that ensured survival during the long night were also the practices that defined what it meant to be Inuit, blending engineering, environmental mastery, and cultural continuity into a single, enduring framework. As winter slowly gave way to the faint return of daylight, the culmination of months of meticulous survival became evident. Every aspect of life inside Inuit dwellings, from the careful placement of the kulik to the arrangement of sleeping platforms, had contributed to the endurance of families in one of the harshest environments on Earth. The skills honed over generations created not just temporary shelters, but sustainable systems that balanced the needs of human bodies, communal life, and the unforgiving Arctic environment. These practices, once vital for immediate survival, also fostered resilience, resourcefulness, and cultural continuity that endured long after the winter thaw. The gradual lengthening of days marked subtle shifts in daily routines. As more sunlight filtered into the snow-laden landscape, the need for artificial light lessened, though the careful management of heat and ventilation remained essential. Families adjusted lamp use, scaling back fuel consumption, and allowing reserves to replenish in preparation for the next period of darkness. The reduction of flame intensity also permitted more frequent ventilation, letting fresh air circulate freely without sacrificing warmth. This seasonal adjustment exemplified the Inuit approach to environmental adaptation, a continuous balance between immediate needs and long-term sustainability. Even as the winter deepened its grip, some techniques used in earlier months were refined or replaced with more efficient methods. Ice blocks that had initially insulated shelters were sometimes reinforced or reshaped to prevent heat escape, while snowdrifts around entrances were managed to regulate airflow. Animal skins, often used for bedding or floor covering, were rotated, dried, or layered differently as the temperature fluctuated. Each modification was informed by careful observation of interior conditions. The temperature, the movement of smoke, and the behavior of the flame. In this way, the home became a dynamic system responding to both environmental pressures and human interventions. Community organization played a critical role in this process. Families communicated about resource management, sharing fuel and coordinating tasks to maximize efficiency. Experienced hunters and elders guided younger members in both the collection of fuel and the optimal use of oil for lamps. Knowledge of insulation techniques, ventilation practices, and sleeping arrangements was passed down orally, often demonstrated through hands-on instruction. In this manner, the entire community functioned as a living laboratory, constantly refining survival strategies through collective experience and collaboration. The use of lamplight extended beyond the practical into the cultural and social spheres. Even in the deepest darkness, families gathered around the flickering glow to share stories, songs, and knowledge. The flame's warmth and illumination created an intimate space where education, entertainment, and ritual coexisted. Storytelling, in particular, reinforced both practical knowledge and cultural identity. Tales of past hunts, survival challenges, and the behavior of the natural world were embedded with lessons on maintaining warmth, conserving fuel, and interpreting environmental cues. These narratives ensured that younger generations internalized vital survival skills alongside the values and traditions of their people. The cumulative effect of these techniques extended far beyond individual survival. Children who grew up learning to manage heat, light, and oxygen developed not only practical skills, but also a deep understanding of cause and effect, problem-solving, and resource stewardship. The necessity of observing flame behavior, monitoring ventilation, and managing clothing layers cultivated a keen awareness of one's environment. This awareness extended to hunting, navigation, and broader interactions with the Arctic landscape, creating a continuity of knowledge that supported both immediate survival and long-term adaptation. At the heart of these practices was a profound understanding of materials and energy transfer. The Inuit recognized that snow, ice, animal hides, and moss could be combined to create insulating barriers, while controlled airflow and strategic lamp placement could maintain a stable microclimate within the shelter. They exploited the principles of conduction, convection, and radiation without formal scientific language, translating observation into practical solutions. Every element of the dwelling, from the thickness of snow blocks to the elevation of sleeping platforms, was chosen with precision to conserve heat and optimize oxygen levels. In this way, traditional Inuit dwellings functioned as highly efficient, energy-conscious environments centuries before modern building science emerged. The integration of these practices into daily life extended to social norms and communal behavior. Families learned to coordinate activities to reduce unnecessary exposure to cold, conserve fuel, and maintain adequate oxygen levels. Children were taught to move carefully around flames, avoid blocking ventilation channels, and contribute to tasks without compromising the delicate environmental balance inside the shelter. This coordination fostered a culture of responsibility and mutual care, reinforcing social cohesion while simultaneously addressing survival imperatives. The success of each household, and ultimately the community, depended on the ability of individuals to follow and adapt these established practices. Seasonal adjustments were also critical for long-term sustainability. As the Arctic thaw approached, families began preparing for increased activity outdoors. Snow structures were repaired to maintain insulation for the remaining cold weeks. Fuel reserves were replenished, and clothing and bedding were dried and stored for future use. Hunting strategies shifted to align with the changing environment, ensuring that food and oil supplies remained sufficient to support the community until the next period of darkness. These transitions were carefully timed and executed, reflecting the Inuit understanding of cyclical patterns and environmental predictability. The impact of these practices extended to psychological resilience as well. The controlled interplay of heat, light, and air within the home provided a sense of security and stability, mitigating the disorienting effects of prolonged darkness. The warmth of the lamp, the comfort of furs, and the knowledge that each element of the dwelling had been optimized for survival contributed to mental endurance. This psychological stability was essential, enabling individuals to conserve energy, focus on essential tasks, and maintain social cohesion under extreme conditions. The shelter became not just a physical refuge, but a sanctuary for the mind, body, and community. Even in the most extreme winters, these practices allowed Inuit communities to thrive. Their mastery of environmental management transformed the challenges of the Arctic into a framework for life, turning scarcity into an opportunity for ingenuity and resilience. Heat loss was minimized through architecture and layering. Lamplight was optimized for efficiency and function, and oxygen levels were maintained through subtle ventilation techniques. These strategies were integrated seamlessly into everyday routines, forming the foundation of survival in one of the most inhospitable regions on Earth. The lessons of these adaptations extend beyond historical or anthropological interest. Modern science and architecture have since recognized the value of insulation, passive ventilation, and energy-efficient lighting, principles that Inuit communities applied intuitively for centuries. The careful observation of materials, environmental conditions, and human needs represents an enduring model of sustainability and resourcefulness. Inuit practices highlight the potential of harmonizing human activity with natural forces, providing insights into energy management, ecological awareness, and communal resilience that remain relevant today. Ultimately, the Inuit approach to surviving the Arctic winter was a comprehensive system, integrating shelter design, fire management, clothing, and social coordination. Each component was interdependent. The flame provided warmth and light, but required careful ventilation. Sleeping arrangements conserved body heat, but depended on the insulating properties of bedding and shelter. Fuel conservation dictated the timing and intensity of all activities. This holistic approach ensured that life could be sustained even under the most extreme conditions, demonstrating a profound understanding of both natural and human systems. By the time the sun returned to the horizon, families emerged not only having survived, but having maintained a rich, structured way of life. Their shelters had served as more than refuges from the cold. They had been laboratories of survival, spaces where heat, light, and air were carefully balanced to create a livable environment. Generations of knowledge, observation, and adaptation converged in these homes, illustrating the remarkable ingenuity and resilience of the Inuit people. The Arctic winter, with its long darkness and extreme cold, shaped every aspect of Inuit life. Yet, through meticulous design and disciplined routines, communities transformed these challenges into systems of survival, learning to control heat loss, optimize lamplight, and maintain breathable air. Their ingenuity offers a timeless lesson in resourcefulness, adaptability, and the capacity of human communities to thrive in harmony with their environment. Even today, the principles developed through centuries of Arctic experience continue to inspire sustainable living and the intelligent use of natural resources, proving that human ingenuity can flourish in even the most formidable conditions. The legacy of these practices is evident not only in the survival of communities, but in the continuity of cultural identity. Stories, rituals, and practical knowledge were preserved and transmitted through generations, ensuring that each new member of the community inherited both the skills and the values necessary for life in the Arctic. In this way, the strategies of heat, light, and oxygen management became more than practical survival. They became an integral part of what it meant to be Inuit, a testament to the resilience, intelligence, and ingenuity of a people in dialogue with one of the harshest landscapes on the planet.